Hi everyone, so today we're going to look at how to measure the execution time of a program. So let's say we have some program that measures the execution time of a function that finds us the sum of a finite geometric series. So as a refresher, consider this series 1, 2, all the way to 256. The starting element is 1, the number of elements 1, 2, 3, 4, 5, 6, 7, 8, 9 is 9. And the common ratio between each element is 2, because if I multiply 1 times 2, I get 2, and 2 times 4 is 2, and 4 times 8 is 2, and so on. If I add up all these numbers from 1 to 256, the resulting sum is 511. The formula for which is shown here, where I have the sum is equal to the starting element 1 times 1 minus the common ratio raised to the number n, so that's 2 to the n to the ninth, over 1 minus 2, where r is our common ratio. So let's look at the implementation. I will show you this specific implementation, but I will also address how to do it for any program, any function, or any class that you might encounter or want to time for yourself. So right here, I have written this program or script in C++ for you to implement if you wish to time any function or any class method that you wish to find the execution time for. So I've done the typical, I've included preprocessor directives, which here are just includes are no macros or ifdefs. I've declared a namespace std. Now I commonly agree that you don't want to do this because it will include the entire std namespace. But for these purposes, I think it makes the code more readable. So I will just leave that there. Function prototypes, I only have my demonstrated function, which is my geometric series, and which is right here if you want to take a look at that. But I will explain and focus on the timing. So we first declare initialize an integer 8, and we set that equal to 0. We then instantiate clock underscore t, which is coming from the chrono library here. And then we create a time required object. This is going to be essentially our execution time. We start our clock by setting it to the return value of clock, which is again from the chrono library. This clock method acts as a way of taking the time from our system. Right now, that's 11:20 p.m. So it takes in that parameter, and then what it does next is it sets a equal to the log of the parameter which it passes, which is the call to our g-series function here. Now, as you can see, I set my initial value to 1, my common ratio to 2, and my number of elements to 9, which is what we have here. So it should give me 511, and it does. It gives me 511. If I were to change this to 10, and if I were to run it again, I would know that it's going to be a little bit more, and I would have added, let's see, 256 times 2, that's going to be 512. So if I add 512 to 511, the result is 1023. So it doesn't really matter, but for consistency's sake, here we are. So notice that the execution time is a lot less. It's a lot faster. It's 8.3 times 10 to the minus 5 seconds. And I get this like so. I first have to take only the duration of time passed, because if I didn't do this step, what would happen is I would pull the entire time from system to here, which is a little bit more, not noticeably more, but it's not correct. I then have to format my time in seconds by doing it here. I divide by clocks per second, and then I return. And that's it. If you want to time your function using this method, simply include your code for that function or functions, and then you'll have to execute this block along with this at the beginning for every time that you wish. So if you had multiple methods, you might want to declare more than one A, or just use one A and then output the time for each specific function. If you had a class, you can do this for a method or each method of that function. I do not recommend passing the instantiation of that class here because that can cause issues. I'm also working on making this method more efficient here using a struct and encapsulating everything, but for right now, it works. You can measure the execution time of any method, any class method, or any function, and I hope you learn from it and make it your own even, or improve on it. Cheers.